Hello, everyone, and welcome to today's webinar, Building for Tomorrow, NPIs in 2021. We are so happy that you are here to join us, and we'll be getting started now. My name is Joel Garcia. I am the marketing lead for Instrumental, and we are very excited to be sharing an amazing
Uh-oh, did we lose Joel?
Still here.
Say that again, Joel, sorry.
I'll be going through the agenda. I'll give some brief introductions for our speakers. We'll be going through the impact of COVID-19 on the manufacturing industry at large. We'll be discussing new advanced techniques with regards to waterproofing technology, nanocoating specifically, AI and correlation capacity. We'll be giving some final thoughts and some tips on best practices you can start using with your builds today, as well as a live Q&A at the end. And if you have any questions, please feel free to submit them below, and we will answer them at the end of the webinar. Thanks.
Hello. So my name is Anna Shedletsky. I'm CEO and founder of Instrumental. I'm a mechanical engineer by background. I was at Apple for 6 years, led a handful of iPod programs, as well as the first generation Apple Watch program. Started Instrumental about 5 years ago, and we'll talk a little bit more about what we do. But I'm really excited to be joined here by Dr. Stephen Coulson. So Dr. Coulson, will you introduce yourself?
Sure, thanks, Anna. Hi, I'm Stephen Coulson. I'm the Chief Science Officer and founder of P2I. So I'm a chemist by background, and it was all a project sponsored by the UK Ministry of Defence looking at protecting soldiers from chemical attack. So we set P2I up back in 2004. Yeah, and excited for this discussion with Anna today.
Great. You want to tell us a little bit more about P2I?
Yeah, so we were founded back in 2004, so a spin out from the UK Ministry of Defence, and we are the global technology leader in protecting electronics from water and corrosion damage. So to date, we've treated over 500 million electronics from mobile phones, Bluetooth headsets and hearing aids from water and corrosion damage. And really why the customers adopt us is they're looking to massively reduce field failure return rates, which is exactly what our technology does. So we have a growing customer base. We work with all the leading OEMs for mobile phones and Bluetooth headsets. The sort of most notable recent sort of customers and products that we've brought online is the Samsung Galaxy Fold 2 and the Motorola Razr. So very much the flip and fold devices that are sort of striving the way as the leading technology. And in order to provide the levels of protections the consumer demands, then the P2I technology is required to provide that level of protection and quality.
Great. And then so a little bit about Instrumental for those of you who are less familiar. So what we do is we are building software to help hardware companies, suppliers, manufacturers and brands find and fix issues in their development cycles and improve process in production. And we do that by building what we call a manufacturing optimization platform. So essentially we take in various types of data from the line, whether that's images or test results or measurements. We pull that into a platform where everyone can see what's going on, whether it's executives who get access to live dashboards in real time that lets them understand the risk profile of a particular program or across many programs. Product design and mechanical engineers can use the software to actually find issues for them, leveraging our AI. They can do virtual teardowns and failure analysis. So this accelerates their finding and fixing process. Quality engineers can look at the metrics and analytics over time for how defect rates are changing, Pareto's and run charts on defect rates, so they can see whether the changes that they're making in the suppliers or at final assembly are having the intended effect. And then of course, operators get kind of what you expect of any kind of technology that's looking at inspection. They're really able to get real-time pass-fail on the line so that they can either put units aside or actually make changes in situ depending on the factory and what operators are doing. So that's Instrumental in kind of a quick nutshell. So maybe before we dive in, just as kind of a high level, because I have Steven here and he has a different bird's eye view on the supply chain than I do. We're going to talk about a couple of kind of core numbers coming out of the research around the impact of COVID-19 on supply chain, on electronics manufacturing specifically. And so we'll kind of dive into a couple of these metrics and maybe just discuss a little bit how they've influenced before we dive into the case study. So the first one is that 53%, do you want to advance, Joel? 53% of electronics programs were canceled or delayed in 2020. This is certainly something that we saw, particularly in Q2 of the calendar year, where there were shutdowns that kind of reverberated across supply chains that did cause delays. But we also saw a couple of companies in the electronic space actually cancel programs. We saw others double down because their products were suddenly, the demand for their products was far exceeding their initial expectations. So this one really resonates with what we saw with our customers and from our perspective in the market, working with both manufacturers and the brands. Steven, what did you guys see?
Yeah, so from our experience, we didn't see any projects cancelled, but we did see them being delayed. And it kind of was inevitable, really. I think as you start to get things like a pandemic, then you obviously have a lot of people who are concerned, and that leads to a lot of risk and delays and people reassessing what is the most important thing for them. So when people start to relook at their products that are out there and their roadmaps, then there are inevitably some delays. And as well as with local lockdowns happening and different countries hitting at different times, then supply chains start to slow down. So yeah, delays are kind of inevitable.
Do you have a sense of like what you saw on average across your customer base or across the companies that you guys interact with? Like, was it like 30 days? Was it just the length of these various lockdowns? Or did they reverberate and actually become longer as the year went on?
It's harder to come up with a sort of a general statement for it, I think, from our perspective. But I think as you start to look at the individual supply chains, it becomes clear as to why that is. So depending on how many times things pass through China or in certain areas that were going through lockdowns at that particular stage, then it would have direct impacts on those. So I think at face value, it's very difficult to come up with a general statement. But yeah, there was mainly delays across the board.
Got it. I think we saw an average of like, generally we see in normal years, we still have delays. And we see them usually being somewhere between like 30 and 60 days for launch plans that customers have. And I think we saw that number kind of go up where we're like in the 60 to 90 day range of delays kind of across the board. So anyway, that was our experience with it. Maybe let's talk about the next one. So if talking about delays and particularly NPI delays, which would be new product introductions, that's development, that's new stuff that's coming out. I was really surprised by this number, which was 79% were due to collaboration issues. I imagine that a lot of the delay, maybe it was production delays were based on supply. And I guess in development, you don't need a whole bunch of units to be able to do development. So you only need 100 chips or whatnot. And maybe you're less supply constrained by the kind of ups and downs of the lockdowns. But this one is quite interesting because certainly it's believable. People stopped being able to travel to these locations to do their collaboration. And so it makes sense that things would just be slower. I know we're going to talk a little bit more about P2I's experience like during this period of time last spring in the case study, but do you have like a quick comment to add to this around like, is this believable or do you think this number might be overstated?
Yeah, I guess it's sort of the basis of where the number comes from, because obviously there were supply chain challenges that we just saw on the previous slide and some cancellations. But I guess from a collaboration issues, it must be due to the interaction of the people. And so it'd be interesting to see as we drill into that, where that 79% comes from. But, you know, I think as people start to tighten their belts and focus in on very specific things, then they have less bandwidth to perhaps look more openly and widely than their own organization. And maybe that's the reflection on it, that it's a reflection of not just bandwidth issues, but potentially mistrust with some of the partners.
I mean, did you stop traveling or reduce traveling that you would have otherwise done? And like,
totally, yeah,
it was down for you.
It was forced on for us because, you know, although we're a UK headquartered company, we are global. You know, a lot of our customers are in the US, and most of the manufacturing of the customers' products and the assembly lines is in Asia. So yeah, our travel got slashed drastically, which obviously pleased our accountants from a cost saving perspective, but obviously makes the face-to-face discussion and collaboration to this point a lot harder. But because it was happening to everybody practically at the same time, then everybody jumped on platforms like we're on today to sort of start promoting that collaboration. But there's always a delay, isn't there?
Yeah, absolutely. Let's go to the next one. So, well, here's what we expect is that 91% of delays were due to component sourcing issues. I think if we add up the 79 and the 91, somehow we're over 100%. So these are maybe from different sources from different groups, but totally agree. I think we've kind of talked about in this one, just like as various times, because the supply chains have gotten so kind of long and brittle as people, particularly US companies, tried to avoid tariffs, which I know some of your customers are US companies. And so probably, you know, experienced some of those more brittle supply chains where pieces were pushed upstream, maybe to India or downstream, and kind of pulling the key pieces out of China that are required to not incur tariffs if you're a US company selling into the US market. And so that made those supply chains more brittle. So that's why it's a problem. Like Wuhan goes down, or parts of China go down, you know, India goes down, or parts of, like, you know, other sourcings where pieces are coming from Vietnam, other places go down, then this creates certainly a backlog of, like, not just in time is no longer working. And so that we definitely saw that brittleness. And I think we talked about this one. So we can maybe fast forward to the last one here, kind of the last number, which is really kind of coming off that tariff comment. You know, at least in the US sphere, there's been a lot of discussion about, like, will the tariffs actually drive significant changes in how supply chains are set up? And we certainly saw it actually, the creation of these more brittle supply chains. But this research suggesting that 33% of companies in 2020 are moving supply chains out of China. Now, this just mean they're moving parts of supply chains or for specific products, but not all. So I think the way the question is worded is pretty critical. But we've certainly seen an increase in diversity of different places that companies are building. And primarily we've seen the large companies are primarily staying put with suppliers they've worked with before in the places they've worked with before. And these are companies that sell into the US market. And then what we're seeing is, like, the smaller companies that are coming out with first gen or second gen products are more likely to start those productions with new partners in non-China places. That's kind of the trend that we've seen. So it hasn't really influenced the big ones, but for the smaller ones, it has. I'm kind of curious if you have any comments around this trend. Is this something that you're seeing, or are mostly people staying put? Are you staying put? Have you had to go into new countries in the last year? Tell us about that.
Yeah, so I think that is true, whether it's that percentage or not, but certainly people are moving supply chains out of China, which was happening anyway, of course, before COVID-19 hit. So it's just a progression. I think people have started to accelerate it more, but probably found it hard to accelerate it more due to the various lockdowns happening. But yeah, I think as the markets mature in other areas and people want to get closer to the market with their manufacturing to reduce shipment costs and lead times and things, then it's not surprising people are moving out, really. And then the various sort of trade wars going on around the world, then I think that just increases the risk profile of China beyond the benefit of the cost savings it provided historically. I mean, you know, as people know who've been working within China, is the labor costs have been increasing massively year on year, to the point where suddenly people are looking at the cost base and saying, well, if you're looking to get the same level of skill as in your local country and needs to speak your local country's language, then you're paying probably just as much, if not more, for those individuals. And so people are starting to bring supply chains back closer to home anyway. So I think this will just potentially accelerate it.
Got it. All right. let's dive into kind of transitioning to talking about the case study. So I think the kind of one of the main underpinnings or themes that Instrumental sees in general is this misalignment across the supply chain that is typically there between suppliers, manufacturing partners, the brands, the systems integrators. There's all sorts of different kind of parties in the ecosystem. And a lot of the times the parties that are working closely together often don't have full alignment, not even just on incentives, but also just like even their perspectives looking at the data that each of them have. There's not a lot of sharing. There's a lot of like siloedness of like, well, I have this data and I'm going to keep this and you have your data. And we try to come together and not show our cards, but still try to solve problems. And I think Instrumental's perspective on this is that there are ways to be, to maintain IP, but also be more open about the problems we're all trying to solve and the data that each of us have to help solve those problems. And so one of the things that we do is we're trying to turn subjective, like, oh, there were some failures, into objectives, like an objective observation of these were the failures. Here are the specific units that have the failures. Here's what they look like. The character is like this. And that will help us together to collaborate across these different parties to deliver great products much faster. One of the things that I remember from my time at Apple is that every time there was a transition from one partner to another, one supplier to another, particularly in the very long supply chains like display stack ups and things like that, there's like a 4-day wasted time where everybody's pointing their finger around like IQC, the incoming quality control guys are rejecting parts that OQC said were fine. And there's just always a sync up that has to happen at every transition. And I think that that's an indication of an opportunity. It's an opportunity to, like, I guess as an engineer, maybe I'm an idealist, but it's like, hey, why don't we all just like kind of share some of our data? Like, you know, in a secure, careful way, but so we can solve these problems faster and get better results. And so on the next slide, kind of talk about how how we can, by breaking down these we can eliminate some of these misalignments by eliminating the data silos between different parts here. And so the way we do that is we take in data from the process. So in this case, in P2I's case, we're taking inputs to their process. So upstream understanding of what it is that they're receiving. They have their process that we're going to hear a little bit more about. And then looking at the outputs from that process. So that could be additional images or it could be functional data. And they have their own functional data that they're also looking at. And then pulling that together. And we've seen some of our customers are able to create correlations here between their inputs and outputs that enable them to figure out what to change about their inputs to their process to actually get the outputs they want. And by doing so, they improve yields and reduce rework and reduce costs. And this is good for everybody. I think like high yields across the supply chain is a win-win-win-win-win. And so multiple parties should be on the same page around how we can collaborate better while maintaining our IP and making sure that we're kind of working forward to delivering the best quality product we can at the best kind of efficiencies. And so that's kind of an introduction to the case study on the next slide. Yeah, so we were really happy to get to collaborate with P2I to put together this case study, which actually takes place during kind of some of the particular drama of the COVID-19 back in the spring of 2020. And I'll hand it over to Stephen to describe a little bit more about what they were trying to do, what the kind of challenges were in that time, and how Instrumental was helpful.
Great, well, thank you, Anna. So let me introduce Dunkable to you. So first of all, when you've got an electronic device, whether it be a mobile phone, Bluetooth headset, hearing aid, there are lots of environmental challenges that can come into contact with that can cause it to corrode and damage. And doing a number of sort of market surveys and studies, we've managed to break those down into 3 particular liquid challenges. So you've got splashes and spills, you've got shallow immersion, whether that's dropped in a puddle or a short immersion in a sink, and then you've got the deep immersion, so like the swimming pool or in the sea. And so what we've done is we've devised our product portfolio to line up with the threats that are out there. And so it's done on a scale of what's called the IPX scale, which for all intents and purposes is an ingress protection scale. And effectively all you're doing is increasing the force of water that's exposed to the device. So for instance, IPX 1 to 2 will be low force, IPX 6 to 8 is much higher. And so our product offerings of splashproof, barrier and dunkable address the very threats that face them. Now, the splashproof is all about repellency. So we apply this to the end product as it comes off the production line, and it protects water from getting inside in the first place to prevent the corrosion damage. But if you do expose it to too much force of the liquid, like if you drop it in a puddle, then water gets forced inside and so will be in contact with the electronics, causing corrosion damage. So then you need to apply the barrier coating technology in order to protect it from corroding. However, if that device is then submerged much deeper underwater for longer periods of time, you need a much more sort of all-encompassing barrier coating with other protection technologies in there. And that leads us to the top end of protection, which is dunkable.
So maybe just to kind of dive in, figuratively, dive in there a little bit more, because I think like as a mechanical engineer, what was really fascinating to me about dunkable is frankly, it puts the paradigm of water protection on its head. Like I was always, you know, I worked on watch and like our whole thing was like, just don't let the water in the first place. And dunkable is actually quite different. Could you share a little bit more about like essentially how dunkable like works, how the design changes when you use dunkable and why that like, what kind of products that's particularly enabling?
So one of the real reasons that we came up historically with dunkable is because when we tried to sell splashproof, which is the same repellent technology that we developed for the MOD years and years ago about providing the maximum level of repellency, although we said to customers for electronics, you know, this is about protecting splashes and spills, they would always throw it in a bucket of water. So that really annoyed us. So we got to a stage where the CEO just said, look, they're always going to throw it in a bucket of water. Just go with the team and invent technology to protect it from that. So that's how we started to look at dunkable. And it also came about because, you know, anyone who's got electronics, it's very difficult to keep water out. And people spend a lot of money putting in gaskets and O-rings and various other levels of physical protection into a device, and water still gets inside. Because the second you drop, bend or flex that device in use, which is what the consumer does, water will then get inside and it will corrode and fail. So we stopped being concerned about water getting inside the device and focused on how do you protect it once it does get inside. And so the team developed a bunch of different technologies that we bring together into the dunkable offering to happily allow liquids into the device so it doesn't cause any corrosion damage or functional failure, but will then leave the device so the user can operate it as the manufacturer intended.
So it sounds like from a like the nitty gritty of mechanical engineering perspective, it's like, so you let water in, then what breaks? And it's like, okay, all the electronic connections on the board that are exposed, so those need to be covered. There's like all of the interconnects, like the board-to-board connectors or ZIFs or ACFs or different types of ways that things are connected there. So those need to be accounted for. Are there other, besides those kind of two areas, are there other like kind of unexpected areas of corrosion that you need to put dunkable on? Or is it really just kind of covering the board?
Yeah, it's mainly those. I mean, it's like anything that would corrode. So anything with a current passing through it when it's exposed to liquid. So it's very simple to work out what would get damaged. And then we've developed this toolbox of technologies to protect it. But it's essential that you have that gas phase deposition process, which is the sort of the platform technology, if you like, to get that molecular attachment to the surface. So it is durable throughout use and it does fully create a hermetic seal around the board. And that's critical in combination with the other technologies to prevent that corrosion.
It also seems like there are certain types of devices that you cannot keep water out of no matter what. I know that like this was certainly a challenge for watch. And I think we managed to go with the strategy of not keeping water out, but you need to still have like a a vent to, so if you take your watch up on an airplane, like it doesn't, and you bring it down at a different altitude, you don't get like the thing exploding itself apart. You need to have like air passing through, and that can be really challenging to have air through, but not water. But there's other devices like, and most notably in my mind, the various kinds of flip devices where I just don't see how mechanically you would be able to seal, like the Galaxy Fold, you know, how you would seal along all those edges. So that's probably not being done. So is this like the only way to essentially provide like water, some kind of water resistance to devices that have bending displays or other types of unsealable surfaces?
Yeah, that's right. I think a lot of products are driving that way, not just to help people differentiate, but to make them more sort of user friendly. And as people try and reduce the weight and size of devices, then you can't afford these mechanical additions in there. But as we already know, the mechanical additions don't work anyway. So yes, you've got to allow the water in, or at least expect the water to get in, and use the P2I technology to prevent that corrosion damage. And there are other incumbent technologies that people have used to protect from liquids from a coating perspective, but they just don't get the durability or the adhesion to the surface or the electrical barrier properties that the gas phase process allows you.
Do you find, last question, then we'll move on. Do you find customers tend to do a belt and suspenders approach where they'll do both the O-ring kind of method to try to keep stuff out, and then, you know, add like a dunkable coating to just as a suspenders for their belt on like the waterproofness of the product?
Sometimes, yeah, it does depend on who the OEM is actually, because if they're used to doing the mechanical fixes, then they feel very confident in that. So they may use P2I more as a sort of a secondary level of protection. And then when they realize that, wow, nothing corrodes anymore, they then start to de-spec the mechanical aspect and realize that the P2I technology is enough to provide the protection by itself. And
how many meters? When you say IPX8, how many meters do you guys market that you can protect an electronic?
Well, when we talk about the IPX scale here, it's all about the device itself. And so the P2I coating, I mean, it is a coating on the surface. So it's no longer about depth anymore, because the whole depth question is about when you blow a gasket or an O-ring. So okay. It all comes down to the availability of the components, but the coating technology will go tens of meters underwater.
Okay, awesome. Let's go on to the next part of your story.
Yeah, so not only were we developing the top end of liquid protection for the first time, we were also operating over a number of different time zones. So the factory we're operating in to deliver this to the customer is over in China. We have our UK headquarters in the UK, not surprisingly, and all of our sort of scientific team there as well. Obviously, we've got a lot of engineers and scientists deployed in the factory in China as well. And then we had our chief operations officer based in the US. So yeah, hence the title, 3 times the time zones, 3 times the collaboration challenges. So we're working across multiple time zones and often multiple languages as well. And then as we look at the supply chain here, you know, what Instrumental gives us is this ability to capture the image of the printed circuit board arrays as they come into the P2I sort of what we call our dunkable secure area. And it allows us to get a snapshot of what it looked like against what the customer is telling us they're going to provide us. So we call that the incoming quality control. And so at that point in time, if there's something not matching up, we can reject it at that point. And then it allows us through the whole of our process to take images and start to map any deltas across them throughout that time in the dunkable secure area before we get to the outgoing quality control. And so we've got a full track and trace system, which works better than the UK NHS system currently, to actually monitor the progress of the devices through our dunkable secure area. So then if there are any issues further down the line, then we can quickly jump back and do some machine learning with the actual software in order to teach it what good looks like. Now, most of these issues are dialed out during the NPI process. So even though we've got a low number of devices coming in, as you mentioned earlier, Anna, maybe just 100 or a few hundred, we can then do the teaching during that process and then we've got a very clear understanding. So when we move into mass production, there are no issues associated with the P2I process.
And you, I believe this is right, you have at least one place on the line in the whole process for this device that's actually shared between you and your downstream customer. At least the data is shared. Is that right?
Yes.
Tell us a little bit about like where that came from. Like how did that particular overlapping station manifest in kind of the relationship between you?
Yes, well, it comes down to the trust between us and the customer as well. And this comes back to your collaboration point and the statistic earlier. And so, there's a need for, as you create all these different sort of stages of a process, each new stage provides a new interface. And that new interface can have low trust between it as you pass from one to the other. So it's, as you mentioned earlier about turning the subjective into the objective, is that really you could have a lot of discussion and a lot of arguments between two phases of a process because of the simple presence of that interface. But if it's very objective with a photograph or an image in this case, then that removes the subjectivity. And suddenly then you've got engineers from both sides who are fully trained to solve problems, focusing on solving a problem and not pointing a finger. And so it's fantastic, yeah, works really well.
Okay.
Yeah, so as we then get into the detail now of how the dunkable process sort of was realized on the line, in addition to the plasma polymer, we're also adding other protective components. And those protective components can move around, they're dynamic. And we have the ability now with this AI system here to be able to take photographs throughout the process and then map how it moves over time to a point where we can say that's a failure or that's a pass. And so rather than our team expending time and energy trying to determine whether this is a millimetre over one way or a millimetre the other way, they can focus on implementing the corrective actions when the system flags in real time to say there's an issue. Now, during the NPI phase, we'll have taught it to say a certain movement is not a fail, it is a pass. And therefore, when we get into mass production, it really is highlighting where the concerns are, and therefore we can make the necessary adjustments very quickly. Also, as everybody wants to be, we want to be proactive, not reactive. And the last thing we want to be doing is releasing product where there are issues. And so by using the system here, you can actually break down the board into a number of different areas, and then you can compare the differences across them. And then they will highlight a delta across it using this new Discovery AI product that Instrumental have. And from that, we can then determine if that is a problem or if it's not a problem. Now, during the whole process of this, our customers were changing their own supply chains. And so sometimes we'd see components that may have moved around. So a registration change, and we could flag that to them before we took the product on board ourselves. They could then sort out that issue as we focused on things within our dunkable secure area. So at least once we then passed it out of the system with this shared AI facility, as Anna mentioned earlier, we both had the confidence that what we had treated is exactly what we were meant to treat and that we hadn't changed anything. And then the final slide on this part is really about the dashboard. So Anna mentioned about the Pareto analysis of what the issues are. So this gives us an ability either to drill in from an executive level or from a corrective actions or failure analysis process and really get to the heart of what the problem is. So we can really focus the team's effort on finding the solution. And so the team now have had this deployed for a number of months now and are fully integrated with it, and it gives us a powerful tool to make those improvements quickly. So when we look at the actual metrics that drop out of it, I mean, it's been a phenomenal impact to our team. So first of all, we used to deploy a lot of people to site. So there are a number of our team who would be constantly on the flights into China during a NPI process. And a number of those got caught up in the lockdowns as well. But this now gave us the ability to manage all this back in the UK at headquarters. So no longer do you have one or two engineers, or in addition to the one or two engineers on site, you also have the whole team of the P2I engineers and scientists being able to look at it as well. So there's a massive increase in our engineering efficiency. And also we could reduce the amount of people who were manually doing this on the site. So I'd managed to only spend about half a day doing this actual check manually, where you would look at all of the dispensed liquid onto the device and checking where all the components were and where the masking and demasking had happened. And it's a very tiring exercise. And so we sort of took all that energy out of the system by deploying the instrumental machine. So yeah, huge increase in efficiency. And really what it helped us do was eliminate those quality escapes. So the last thing you want to be doing is giving poor quality product to your customer. So it prevented us from doing that. It made sure that we could iron out our own mistakes internally and perfect our standard operating procedures. And then if there's any rework that happens, then we could do that quickly and effectively. And the travel one we've already mentioned a number of times. So that was a huge cost saving from that perspective.
Let's maybe just dig in one layer more, because you talked about how before the session, you talked about how you've been able to kind of leverage the learnings from one generation product to the next generation product, because there's more than one thing that we're working on with you. Could you maybe, like, I think that's a kind of an unsung benefit of having better data, is how that influences more than just the one program that it's on. Maybe tell us a little bit about how you're able to like leverage generational data from one product to the next.
Yes, we've dialed out quite a lot of the unknowns. So a lot of the components from product to product stay quite similar. And so therefore the artificial intelligence, the machine learning that we've taught it during the initial stage in the initial products are something we can apply to the next one. Now, it doesn't solve all the issues, of course, because every design is unique, but it certainly made a big improvement with regards the ramp up time to get to zero defects. So it's been difficult to actually quantify that, but the team visually look a lot more relaxed when we brought on the next product, because they could actually use a lot of the sort of the learnings from the previous exercises. So yeah, that was nice to see in the eyes of the people working on it.
It seems like the product maturity, essentially, even in NPI, started at a higher level the second time than the first time, because
yes,
there was a lot of like learnings that were able to be incorporated into the process that were still in place. And so
that's right.
Yeah. I think that like intergenerational benefit is one that's like a lot harder to measure because it's hard to know like what it would have been without. But we certainly see that across customers who have like used instrumental from generation to generation, being able to just start at a more mature place than they felt like they otherwise would have. But yes, It's a little squishy. Awesome. So kind of as like a quick wrap up before we get into the Q&A, and we'd love to, if you have questions, type them into that Q&A. There's a button down in the bottom. We'd love to get your questions, and Stephen here is to answer your questions about either dunkable, instrumental, all of that. Happy to do so. And in the meantime, I'm just going to kind of wrap up with a little bit of like some 4 kind of actionable tips to building better in 2021 as we kind of look forward to this new year. We acknowledge that we're probably going to go through another NPI with pretty restricted movement. And this time we don't have the excuse that we had in 2020 where we didn't know it was going to happen and we had to scramble. So we got to kind of plan ahead, or we have the opportunity to plan ahead. So one of the kind of core pieces here is to define your remote communication strategy in advance. So we certainly saw many of our customers kind of scrambling back in the spring to doing 8-hour FaceTime calls and working, the night shift from California to be able to support day shift in China. And so I think just actually putting parameters around what the expectations are for how there's going to be communication between the different parties at this time, taking in those learnings is an area to kind of move forward on. Identify potential sourcing issues and find backup suppliers. We're seeing some of our customers look at where they could build, actually moving to different locations where it might be easier for them to actually have factory access. We've seen a lot of smaller companies that are US based actually bring manufacturing in-house, which is something that feels anachronistic when we've kind of gotten used to in the last decade, this concept of the relationship between the contract manufacturer and the brand. But we're seeing that actually be quite successful. And we're seeing folks identify more than one supplier for their key parts. So if there is a particular shutdown in a region, they have an ability to move forward with their NPIs. I think there's certainly some thought to be done around defining your threshold for travel and risk on a program. So maybe that means that you should plan on the program taking 9 months instead of 6. So that's a way you handle risk. And then of course there's all the safety implications of travel itself, which I won't even get into. But I think thinking around what are the levels of risk that we're taking on this product, if it's a very aggressive new product with lots of new stuff, maybe trying to not plan to have a line-to-line schedule out the door is a good way to make sure that you'll be able to meet that schedule at the level of quality that you expect. And then the last one is really around optimizing what you can control. So there's lots of things that are kind of out of all of our control, but there are things you can control. You can go in with a strong plan, planning for disruption, planning for just in case versus just in time. And that's certainly our recommendation to our customers, and something that I think a lot of our customers understand that they should be doing, but as they're like doing tool releases right now, it's a busy time in Q4, getting ready for NPI season in the electronics industry in the spring, that can kind of fall by the wayside. But I think it's just as important thinking about how you can optimize the things that you can control, your data, your product, the decisions you're making, how much risk you're taking on, so that you can have a successful NPI and ship on time in the summer when hopefully we have vaccines and things are starting to open up and look a lot more normal. So those are kind of our core tips, and I'd love to, looks like we've got some questions in, so I'm gonna hand it over to Joel, who's gonna moderate for questions for us.
All right, I think I need to stop screen sharing for a second or get out of display. All right, first question. What makes inspecting a nanocoating so challenging in the first place?
Well, certainly from my perspective, I mean, because it's so thin, I mean, the actual coating we're depositing with the plasma deposition is incredibly thin. So it's very difficult to get a signal from that. So you've got to get the right analytical tool to be able to make that detection. And then you want to know from a liquid protection perspective that it's covered the entire site. So yeah, it becomes very complex.
What did you try before instrumental as far as quality control?
Well, we used to do manual. So that was the pain we were experiencing. I mean, remember the Dunkable was a very new product offering for us in the fact that it was pushing the boundaries of the science that was out there at that time to be able to deliver that level of protection that the mechanical seals couldn't deliver. So as you invent new technologies, you need to develop and invent new ways of detecting it and getting confident that it will give you the performance you want. So yeah, it was a manual approach initially. And then we've managed to, as we've described today, get the subjective into the objective by using instrumental.
Mm-hmm. All right, this one is from Charles. Thank you, Anna and Dr. Coulson. How is the coating presence and its thickness measured?
So the presence is measured using the instrumental device. We've got ways in which we can sort of detect the coating with sort of proprietary ways of doing the analysis. We've also got another system that we can build into it. So that's how we can detect it. And then the thickness, there are general thickness measurements out there, sort of off the shelf ones that can be used to measure coatings like Filmetrics, for example.
This one is from an anonymous attendee. For Stephen, in terms of remote monitoring, what did you look at every day to make sure your line was running smoothly? Did you rely more on functional tests or visual tests?
We do both. It's essential we do both. So we've got to know what the functional tests are, because at the end of the day, it's about preventing corrosion damage. So we need to do those checks to ensure that the coating we're depositing is of the right quality and doesn't cause corrosion. And then the second part is to be able to check visually that that coating quality is over the entire board to show that we wouldn't get any corrosion damage. So it's essential you bring those two together which is why the tool and the software behind it is so important to bring all those inputs together to generate that one output that will give us the confidence that we're delivering the quality that the customer wants and eventually the consumer wants in reducing field failure return rates.
I think you also mentioned you guys had built some additional kind of database or piece of software where you were actually able to take the learnings from your various data streams and actually make changes eventually even remotely. Could you maybe share a little bit more about, essentially that's a closed loop for the mechanical engineers on the line, that's closed loop feedback. How can you share, what can you share, I guess, about that, like the other half of that, the pushing back a change to the line?
Yeah, I think like with a lot of these things, as we start to try and extrapolate it to minimizing any interaction and any downtime, etc., then we'd love to be able to carry on driving towards that feedback loop where when we measure something that's incorrect, we can interpret that to what the changes are on the machine. We're not there yet, but there's no reason why we can't be there in the future to be able to actually pinpoint the issue from the instrumental image to what device needs changing and by how much. And so though we'll keep building that database and keep building that ability to drive that automated feedback so effectively it can control itself.
Cool. We have one more question from Don. Kudos and congrats, Anna and Stephen. Impressive collaboration. Question. Generally, how long does it take to design/implement an instrumental remote solution? A couple of weeks, months, quarters?
Well, I can kind of answer in general, and then maybe Stephen can share his specific experience. So in general, we work with our customer during essentially the sales process to actually understand their program, the challenges they see. We have a team of mechanical engineers who've shipped stuff in volume before, who work with your team to kind of suggest and design the best solution. This process is not long. It takes maybe an hour of collaboration to do that. And then we put together this proposal. And then once as two companies have decided to work together, the actual implementation is pretty quick. We can be on your line within 4 weeks, typically. If you're in a typical location on the planet, then we can. And generally we get up and running and you'll get first insights the first day we're on the line. So within 12 hours is typical that our customers will actually see first data. So many of them actually find a previously unknown or unidentified defect that they're able to identify in that first 12 hours. And then as Stephen described, like over time, there's a kind of a training process during NPI so that you can get, in NPI, you don't need it to be perfect. You need it to just find everything. And then you can essentially train it during NPI to get to that production grade performance that you expect and require to be able to allow something to run on a production line. And typically it takes us, we can start being useful after the first 30 units. And then generally we can get to production grade performance by the time we've seen about 100 units and had maybe 2 or 3 failing examples to train on. Stephen, did you have anything to share?
Yeah, from our perspective, that's exactly how it happened, of course, with us. And the customer we were working with, they'd already deployed instrumental anyway. So it was a fast start for us. And then, as Anna says, it's not the time frame's a difficult one because it's more about the quantity of product that's coming through. If you can get that quantity through quickly, then you learn faster. So it is a machine learning tool and artificial intelligence that will allow us to better predict things. So yeah, I think the team saw added value straight away as soon as it was deployed on the line. So yeah, it was a very good fast startup, really.
Here's another from Charles. Is this coding process inline or at a remote location? And is there a limitation to the part size?
So for our perspective, it's in line. So yes. So and then from a limitation of the part size, I mean, I'll pass that one to Anna. But from our perspective, it will cover all mobile phone geometries. So I've not seen a limitation there from our experience.
What's the biggest item that you've currently coded, or is there an upper limit to being able to apply the nanocoating?
Oh, it'll be the size of a vacuum chamber. So we've got a vacuum chamber, you know, sort of 2 meters by 1 meter square. So
you put something really big in there.
Put some
like
pretty
if you
big in
wanted
there.
to put like a server, if for some reason someone's building an underwater server farm.
Yeah, absolutely. Yeah, and you can get one of those under your camera.
Well, so good question for that. So we have several kind of standard sizes of our, for those who are less familiar about Instrumental, we are a software company, but in order to accelerate our customers' ability to get data quickly, we do have an off-the-shelf kind of drop-in camera station. That's not, you don't buy it, it's not expensive, it's just like a vertically integrated, so you can drop it in and get data right away. That's how we get to that really fast start we were just talking about. And so the question of like, how big can we inspect? We've worked on stuff up to the size of a washing machine or appliances at that scale. So like 0.5 meter by 1 meter kind of inspection. Certainly, we are mechanical engineers, our solutions architects will work with our customers to identify how we can best inspect at the resolution they need to find the things that they're going to be most interested in. Our standard off-the-shelf stuff, we have a size that works for like up to like maybe an iPad mini or like a phablet kind of phone. And then we have a size that works up to like a laptop. And then anything bigger than that, we use engineering Legos to essentially build out 80/20 and stuff like that, to essentially build out equipment to be able to do that inspection.
All right, we've got a few more from an anonymous attendee. We are constantly struggling to step over the line from being aggressively reactive to acting proactively. Can you give an example of a situation when you were able to actually, when you were able to proactively prevent an issue?
Well, from our experience, the issue for us really is when the customer would see the quality fail. So effectively, the deployment of the instrumental system prevented that from happening. So therefore, I would say that's the proactive step to build in this objectivity right from the start to ensure that what we release from it, we're all confident is going to give the pass we're looking for. And that's, you know, obviously a credit to the team who worked on it and deployed it.
And I would say, just to add from an instrumental perspective for what our customers see all the time. So if you don't find things upstream, where you generally find them is either at functional test or not at all and in the field. And we've definitely caught things that, you know, on the first example that would cause downstream related issues with our customers. So that could be things like damage that would cause antenna failures or speaker failures or functional test failures. We've also caught types of damage that might cause, for our mobile phone customers, things like dropped calls in the field, but it's actually very difficult to identify in a functional test. So certainly our customers are more proactive and able to be proactive by finding these defects at their source. And it's a lot cheaper to fix something, you know, at its source than after you've already added on many components downstream. And it's also a lot less complex because you're able to see like exactly kind of what went wrong and where, and pinpoint in your process where. So it can help you actually solve the problems. That's what Instrumental likes to describe, is that it's not just about finding issues at the end of the line, it's about eliminating them in the first place. And if you're interested in issue elimination, then this is a really helpful tool for that.
Cool. We have a couple more. Is the P2I's instrumental inspection integrated into the customer assembly line or done at P2I's own site, or both?
So from our perspective, then we include it into our product offering. So that's part of what we do. That helps us get confident on what we're releasing. And then the separate contracts, obviously, with Instrumental and the customer as to whether they do it as well. In this particular example, then the customer also used Instrumental as part of their assembly test procedure. So that's why we're able to integrate it at certain stations, because it was a node for both of us. So therefore we could share it while still protecting our intellectual property.
This ties into a question that someone had asked prior to the webinar, which is, if I'm an Instrumental customer already, how do I approach the conversation with my suppliers about implementing Instrumental?
Stephen, do you have thoughts on that, or do you want me to respond?
Sorry, from my perspective.
Like as a supplier, what advice would you give to downstream clients who are maybe interested in having this conversation with their suppliers about instrumental?
Well, if you want an objective way of determining whether what you think you're creating is what you've created and is passed on to your customer as you intended, then this is an objective way of doing it with a great user interface. You can do the machine learning, so you sort of amplify your time for the future, and you create that efficiency. So yeah, I think it works across the full supply chain. I mean, from your experience, Anna, have you got a sort of an example of a fully vertical integration, even though it's across multiple suppliers?
Yeah, we have a customer where we are in 5 different facilities all along the chain. They have a little bit of a different kind of structure to their supply chain. Like most supply chains are linear. They have a linear supply chain, and then kind of we're also in their refurbs and return center because they're collecting data to understand how they could potentially reduce returns by, they actually do testing when they get returned units in to see if they can identify that there might have been a worthwhile reason for the return versus, you know, like a no trouble found kind of return. So we've certainly seen that. We've actually seen, particularly this year, us getting kind of pushed up into these additional parts of the supply chain, not because customers don't trust these suppliers. Our brand customers don't trust the suppliers. Certainly they have immense trust in their suppliers, otherwise they wouldn't work with them. But because it's a way to just kind of cut through the noise of like having a shared data set that everybody can agree on is reality. And then like you said, I really liked how you said it, Stephen, then your engineers who are trained to solve problems on both sides can like have a shared sense of reality and it's objective. And so they can go solve the problem. It's like much faster than the kind of the back and forth. So we also see that like that kind of interaction as well with between clients and their contract manufacturing partners, for those who like work with manufacturing partners like Fox or Flex or the many numerous ones that there are, that actually the contract manufacturers end up using instrumental to essentially have that shared sense of reality, of objective reality around like what are the issues and where are they coming from. And a lot of times the contract manufacturer might be, or the supplier might be the first one to get blamed. That's the kind of the Apple way anyway. It's like, as the designer, you're last on the list that it's your fault. It's like everybody else's fault first. And so the faster you can get through that list of like, was it workmanship? Was it the supplier quality? Was it this? The faster you can get through, the faster you can solve the problem. So we've certainly seen that, more and more of that.
All right, we are 2 minutes to the hour where we will have a hard stop, but we have time for a few more questions. So if you have any last ones, we will answer them either live or we will get back to you via email. This one is also from an anonymous attendee. Is the nanocoating effective against all liquids, salt water, soapy water, juice, or soda?
Absolutely, yeah. Dunkable coating's there to protect from all liquid threats. You know, as mentioned, it was developed for the UK Ministry of Defence, so will repel all chemical nasties.
What is the most aggressive chemical that you use to evaluate the protective capabilities? Like I remember that essential oils and perfume and DEET mosquito spray was like kind of the most aggressive from the watch days. What are your guys' most aggressive chemicals?
Yeah, exactly. I mean, we're all following the same test protocols here. I mean, it's those chemicals, and then obviously from its origination, we used to test it against nerve agents. So VX, mustard.
Okay. Got it. Safe.
Pretty much
Very
at the top
safe.
end.
All right. We'll answer one more question and then we will end the webinar. But were there any challenges in your assembly, Stephen, which caused P2I to adjust parameters and pass-fail on the fly? From Neil.
Well, on the fly to start with, yes. But I mean, I think during the NPI phase, once we had instrumental deployed, then it became a lot more objective and controllable. But certainly in the early stages of deploying a new technology with new capabilities in a different environment, yeah, there's a lot a lot of challenges there that need to be addressed. And then it's really, again, taking that professional approach of getting all the standard operating procedures set up and formalizing that, so it's a much more controlled affair moving forward. And you've got this chance during NPI where it's a movable feast with our customer as well as ourselves. So that is the phase to do your learnings and get your act together, and then you can roll it out in mass production.
And I just want to dive in with the one last question that came in around ROI. Does this pay for itself? So for instrumental, for sure, this pays for itself. We wouldn't get very far in the manufacturing business with very practical people that work here if this didn't have strong ROI. And I'll let Stephen address the ROI of P2I and their coating.
Yes, it's always essential to measure the ROI. At the start, it was all about not releasing quality defects to our customer, and that's a harder one to sort of make tangible and put into those calculations. But with regards, the saving on travel costs and also on the ability to reduce the amount of engineers working on it, then yes, there's a positive ROI.
Awesome.
Great. Well,
thank you everybody for coming. Thank you so much, Stephen, for joining us as well.
You're welcome. Thank you for the opportunity, and thanks for everyone joining and the questions that come in, and good to see a few names that I recognize on the list that I've just had a quick look at. So thank you for your time.
Thanks. Have a good day.
Cheers. Bye now.